All right, welcome back. We're in lesson 24. We're going to talk about some fractional equations. All right, we know how to work fractions. We know that in order to add and subtract fractions, we have to have a common denominator, right? And we can do that just fine when we're looking for the answer. For instance, we have 5 over 11 plus 2 over 11. We know we can get 7 over 11, right? We even know that we could say 5 over 2 plus 2 over 3 equals some number, right? And we could find a common denominator of 6 and multiply by the opposite denominator, and we would have 15 over 6 plus 4 over 6, and we could find out that that was 19 over 6. So we know how to do that. What if we have a denominator in our result that isn't the same? How would we do that? So for instance, we're given a value of x, and we need to solve for it in our equation. It's a part of the problem. So let's look at some expressions that have that. So 24.1. First of all, we are given a mixed number. I hate mixed numbers. Mixed numbers are just messy. They're just messy. I just don't like them. So we're going to get rid of them by turning them into what? Yes, improper fractions. So this becomes 9 over 2. And this becomes, well, this stays 3 over 5. And then this becomes negative 5 over 4. All right, so how do we make those have a common denominator? What we have to do is we have to look at the factors of each denominator and pull out factors for the factor that's used the most times. Okay, so looking at 2, we know that it's 2 times 1. Factors of 5 are 5 times 1. Factors of 4 are 2 times 2. Okay, we know we can drop the 1s. We don't need those. So now we see we have a 5, and we have a pair of 2s, but we also have another 2. So we are using 2s 2 times. So our least common multiple is going to equal to the factors of 5 times 2 times 2. We're going to use those factors in order to multiply each of these fractions and take them to a place that we can actually perform a calculation. So we're going to say 5 times 2 times 2 times 9 over 2 x, same thing, minus 5 times 2 times 2 times 3 over 5 equals 5 times 2 times 2 times 3 over 5. I'm sorry. I was looking at this one when I wrote that. It should be times negative 5 over 4. All right, so now we can do this calculation and simplify it, or we can just factor out the common factors ahead of time and only multiply what we really need to multiply, right? So 5 times 2 is 10 times 9, that's going to be 90x. And this is 2 times 2, which is 4 times 3, that's going to be 12. And 2 times 2 is 4, so we eliminated both of those, and we eliminated the 4. So 5 times negative 5 is negative 25. Now we can actually solve this problem. And we take this negative 12 over here. We're left with 90x equals a negative 13, because when we change sides, we change signs. negative 25, positive 13, or positive 12 leaves a negative 13. So x is going to be equal to negative 13 over 90. Far as you need to go. Okay, so 24.2. We have, here we go. That's 5. All right, I want you to pause the video and then see if you get the same answer when you come back and press play. All right, if you got x equals 43 over 24 for 24.2, then you got that one correct. And if you need to pause the video and go back and look at your notes, if you did not get that answer, see where you made a mistake. We factored out 5s here, 2s here, 3s here. And then we did multiplied and got this. Then we did our distribution and got this. We squished and flipped and got this. And then we divided. So go back and look at that if you did not get 43 over 24. We have one more to do. And that's going to be 24.3. All right, so we only have 2 factors here to deal with, 2 denominators. Again, pause the video, work the problem, and then press play to see if you got the right answer. All right, so we should have gotten, or you should have gotten, the answer x equals 2. If you did not get x equals 2, then you need to check your steps here. Pause the video and look and see what you got. We know that 2 and 7 are prime numbers, so we're going to have to use those as our factors. We multiplied those times each fraction and the whole number, and we canceled out where we could. We canceled the 2 here, the 7 here. We couldn't cancel out anything here. So we got 21x plus 2 times 8 minus 4x equals 42. We did the distribution, we did the squish and flip, we did the division, and we got x equals 2. All right, moving on. I'm going to clear the page, pause if you need to write your notes. Let's talk about overlapping triangles. It makes sense if you think about it. If you have a triangle, and, oh goodness, let's make that meet right there. There we go. All right, if you have a triangle and you have a parallel line here within that triangle, you have a triangle here and you have a bigger triangle here. And it makes sense if you think about the fact that they both share the same angle here. This is the same angle within both triangles. So it's going to be a point of reference for us. We also know if these lines are parallel, we know enough about transversals to know that this will become parallel, or congruent, sorry, not parallel, to this, because these are parallel lines and transversals create congruent angles among parallel lines. That also tells us that this angle is going to be congruent to this angle. And when you have all 3 angles congruent to one another, you have similar triangles, and the similar triangles have a scale factor that you can multiply against in order to get where you need to go. So we are going to look at the dimensions of this triangle here. That we're told this is 4, this is 7, and this is 9. So that's our first triangle. Now, to make it easier to look at, we're going to separate the bigger triangle out. So I'm going to copy this triangle, copy that, and paste it over here. And I am going to use my eraser here. And on this side, I'm going to get rid of the bigger triangle. And on this side, I'm going to get rid of the smaller triangle. Okay. Now, on the bigger triangle, we are told that here, or right about here, and right about here, is where these dimensions hit, right? We're also told that this is a 6, and that we don't know what this is, and we don't know what this is. So that gives us a scale factor here that we can reference. Now, if this is 4 and this part is 6, we can add those two together and get a dimension of 10 for this side. Now we have all the information we need in order to find scale factor and the missing dimensions. So let's look at the scale factor. So 4 times some scale factor equals 10, right? So when we divide, the scale factor ends up being 10 over 4, and we can reduce that to 5 over 2. That's our scale factor that we're going to use, right? So now we need to be able to figure out how to get here. We don't know what x is. We have no clue. And we have a choice how we want to figure that out. But before we do this one, let's do an easier one. Let's do 9 and y. So we know that the scale factor is 5 over 2. So we're going to say 9 times that scale factor is going to give us y, right? Just like before. So 45 over 2 equals y. So we can do our division here, and we know that 22 and a half is the dimension of y. So that equals 22 and a half. And that's fine, right? We can see that. However, with this one, we don't know what x is, but we know that part of it is 7. We know that this dimension is actually going to equal 7 plus x. All right, in order to find x, we have to take the whole thing. So we are going to say our side here times whatever our scale factor gives us. So this is the number we use, 7 times our scale factor, to give us this. So 7 times our scale factor is going to give us 7 plus x. That's going to be our answer. Because it's not just x, it's the whole thing. It's 7 plus x. Right, so let's look at this. We have 35 over 2 equals 7 plus x. So now we need to find some way to make these relational to each other. And the easiest thing to do is to get rid of this fraction on this side. So we're going to multiply both sides by the number 2 in order to just get rid of this fraction. It's going to be easier that way. Just like what we did with our previous problems where we multiplied to get the same denominator, that's what we're doing here. So 2 times this, and then 2 times this. And because we're doing it to both sides, it keeps the equation true. So let's say this is 35, this is going to be 14, and this is going to be 2x. And the reason this stays 35 is because this cancels. All right, so now we can do our squish and flip. So we bring this number over, and it becomes a negative, and that's going to be 21 equals 2x. we divide, and we get 21 over 2 equals x. And so that leaves us with 10.5. So now we know that 7 plus x, x is 10.5. So our dimension here, we can say 7 plus 10.5 equals 17.5. And this is what this entire thing equals. Is that right? Yes. Yes, that's correct. Because we have 7 and then we have the 10.5. So the whole thing is equal to 17.5. Yeah, for a minute it just kind of threw me. I'm taking medication for my sinus, so, I'll blame it on the medication. Anyway, that is how we just continue to use our scale factor the way that we know how. But we had to remember how to use our common denominator with the least common multiple in order to resolve this conflict here in this problem. And which is probably why the book paired the scale factor and the common denominators in the same lesson. That is all we have for lesson 24. I'll see you in lesson 25.